Hello students, welcome back to our JEE Prep channel. Hope all of you are doing well as usual. In the previous lectures, we have studied the concept of speed, velocity and acceleration. Now today we will do the equations of uniformly accelerated motion. Now what do you mean by uniformly accelerated motion? Uniformly accelerated motion means body is moving with a constant acceleration. The body is moving with a uniform acceleration. Means the speed of the body, the velocity of the body is increasing uniformly. Now let us consider this case. Let the body is at point O. Now here the body is at rest. So therefore the velocity here is 0. But now I have applied force and the body starts moving. So body comes to this point A. Definitely his speed is more than this. So I am going to consider the motion of the body from point A to point B. So this is the initial position and the velocity at this initial position is u. I will call this as the initial velocity. Now as the body is accelerating continuously, so the velocity of the body is increasing. So let v be the velocity of the body. As the body is continuously accelerating, so the velocity of the body is increasing. So let v be the velocity of the body at point B. V be the velocity of the body at point B. So B is the final position. So v is the final velocity. Final velocity means velocity of the body when body is at point B, and s is the distance between point A and B. And the body takes time t seconds to reach, point B. So I'll repeat this. Let u is the initial velocity of the body. That means the velocity of the body at point A, because I am going to consider motion of the body from point A till point B. So P is the final position. So V is the final velocity of the body. The body is accelerating with acceleration A uniformly, and body takes t seconds to move from point A to B, and s be the distance between point A and B. Okay. Now then what is the acceleration? Acceleration is equal to change in velocity upon time. Now what is the change in velocity? What is the final velocity? V. What is the initial velocity? U. So final velocity minus initial velocity upon time t seconds. So this gives the acceleration of the body. This gives the acceleration of the body. Now let us simplify this further. So A into t is equal to V minus U. Hence V is equal to U plus AT. So we call this as the first equation of the uniformly accelerated motion. Now let's find out the another equation. Let's find out the second equation. Now second equation is all about the finding distance s. Now we want to find out the distance s. Now distance s is equal to average velocity into time, because velocity is equal to distance upon time. Therefore distance s is equal to average velocity into time. Now what is the average velocity here? So initial velocity is u, final velocity is v. So this is u plus v upon 2 into t. Now we have one first kinematical equation, that is v is equal to u plus at. Now what we'll do, we will substitute this value of v in this equation. So we will substitute the value of v in this equation. So we will get s is equal to u plus at bracket complete divided by 2 into t. So therefore s is equal to, open this bracket, u plus u, 2u plus at into t by 2. So this will be 2u into t by 2 plus half at square. Now this 2 will cancel and the second kinematic equation or second equation of uniformly accelerated motion is here. S is equal to ut plus half at square. So very simple thing. So we have got the first equation of the uniformly accelerated motion as v is equal to u plus at. Second equation as s is equal to ut plus half at square. Now let's go for the third equation. Now let's find the third equation. Now we have got two equations. The first equation is s is equal to ut plus half at square, and second equation is a is equal to v minus u upon t. I will find the value of t, that is v minus u upon t, and I will substitute this value of t in this equation and I will simplify. So I will get the final formula. So now s is equal to ut plus half at square. Now I will substitute for this t. So therefore s is equal to u into v minus u upon a plus half a into v minus u upon a the whole square. So now let's simplify this. S is equal to, open this bracket, u v minus u square upon a plus half a into v minus u the whole square upon a square. So now here a will cancel. So we will get here uv minus u square upon a plus v minus u the whole square upon 2a. Now let's take LCM and open this bracket. So LCM is 2a. So this will be 2 into uv minus u square plus v square plus u square minus 2uv. So this will be now 2a 2uv minus 2u square plus v square plus u square minus 2uv. Now see this 2uv and this 2uv will cancel because signs are different. Now this will be v square and then minus 2u square plus u square will be v square minus u square. So therefore s is equal to v square minus u square minus 2u square is u square divided by 2a. So hence we have now 2as is equal to v square minus u square. 2as is equal to v square minus u square. Hence v square is equal to u square plus 2as. So this is the another last kinematic equation. So we have three equations of uniformly accelerated motion. Which are the three equations? First is v is equal to u plus at. Second is s is equal to ut plus half at square. And third equation is v square is equal to u square plus 2as. So these are the three kinematical equations, and they are also known as the equations of the uniformly accelerated motion. Now students, you will have to remember one concept. Whenever in the problem it is mentioned that the body starts from rest, then take u is equal to 0. So point number A, if body starts from rest, then u is equal to 0. Second, if body comes to rest, then take v is equal to 0. Third, if body moves with constant speed or constant velocity, take a is equal to 0. So this will be very much helpful while solving the problem. I hope all of you understood these three kinematical equations. And students, you have to be very well versed with these three kinematical equations, as we require this in many concepts. I hope all of you understood these three kinematical equations, or these three equations of uniformly accelerated motion. And students, to understand more and more concepts in physics, I request all of you to subscribe our channel. Thank you.